Okay, so we are continuing our journey through a new topic, matrices. Last time we met, we talked about what it meant to multiply a matrix by a scalar, that is, a single number out the front. Um, Today, we're going to do something very different. We're going to take two matrices, so two rectangular blocks of numbers, and we're going to multiply them by each other. And this, I think, is the first major hurdle for someone learning matrices for the first time. Most people find it a little bit challenging, so I've got quite a few examples that we'll work through. I reckon read the first page after. Don't try to take it all in now because it's very dense. So let's turn straight to the second page and look at an example. So it's easier to do it than it is to explain it. So I'm gonna just do it and then I'll explain what I've done. So for reasons I will explain in a moment, when I multiply the two matrices, I will have four numbers. But what I am not going to do is match the numbers in the same position the way we did with addition. And if we have time today, we can do an example showing why this is going to be more useful than the natural alternative. So let's start with the first number. So this is the number in row 1, column 1. So the way we do this is we use row 1 in the first matrix. So I encourage you to circle that on your sheet. Row 1 in the first matrix and column 1 in the second matrix. So this single number is going to be 1 times 10. So I'm taking the first number and then I'm going to add 2 times 11. And that corresponds to the second number in each measure. Yes, Casey?
How come column one's on the right hand side?
It should not be. Thank you. Yeah, column 1 is this one. Apologies. Thanks. Yeah, so 1 times 7 plus 2 times 8. Okay. Now we're going to look at the number in row 1, column 2. So far, I've only calculated 1 out of 4 numbers in my final matrix when I multiply A times B. This time, I will use row 1 in the first matrix and column 2 in the second matrix. And this time I will do 1 times 10 plus 2 times 11. Add those together. Get our answer. Are we okay so far? I hope that the matrices with the circles are making this clear, because I didn't do that last year. So now I'm looking at this number, row 2, column 1. What do you think we should do this time?
bottom row and then first row.
That's it. Row 2 in the first matrix, column 1 in the second matrix. And we can do this a bit more quickly. For the last one, we'll use row 2 in the first matrix, column 2 in the second matrix. Now, our final answer, if we were to multiply the two matrices together, we now put all the four numbers together. So 23, 32, 68, and 95. Please note, it is not 1 times 7, 2 times 9, 4 times 8, 5 times 10. We are not doing this for matrix multiplication. We're using this process involving a row in the first matrix and the column in the second matrix to generate individual entries in the final matrix. All right, is anyone still writing? Okay. Now, you might be thinking, that was a lot of work. Yes, it was. So, most of the time in general maths, you will be able to use your calculator to do this. The reason why I'm emphasizing the by hand routine today is because we expect you to know how to do this next year. We can assess your understanding without requiring you to do a calculation. All right, turn the page. So now we're looking at example 2. You'll notice this time I have not broken it down to number by number. I'll just demonstrate this to you now. So let's say I wrote the two matrices next to each other for multiplication. This is what your working out will probably look like in your workbooks. So I'm going to need a lot of space because they're big calculations. So let's start with the number in the first row, first column. I need to use the first row in the first matrix, first column in the second matrix. Don't circle them because you'll get a very messy matrix at the end. And then when I go over here, I need to use this column. So it'll be 4 times negative 6 plus 7 times 8. And I've completed my first row. In the bottom, I need to use the second row, and we'll start with the first column. So minus 3 times 5 plus 2 times 9. And for the last column, I will use the second column of the matrix. Minus 3 times negative 6 plus 2 times 8. If you're asked to do this with a calculator, obviously just write the answer, but if you're asked to multiply two matrices by hand, I strongly recommend you show your working out like this, and then simplify one step at a time. Yes. Yes, you can. Okay, be careful with negative signs. So if I multiply a positive number by a negative number, my answer is negative. On the other hand, if I multiply a negative number by a negative number, I end up with a positive. All right. I'm going to let you guys have a go now. So we'll spend a few minutes. I want you to repeat this process with the matrices reversed. So I'll set up the first number for you. 5 times 4 plus negative 6 times negative 3. I want you to calculate what happens when I multiply the matrices in this order, and we'll discuss whether or not we get the same answer. Okay? So just spend a few minutes trying this. I've set it up for you, and then we'll chat briefly once you're done.
Which way is it going? So choose the row of the first matrix and the column of the second matrix. Which column are we doing the second one?
So if I'm here, I want to use the second column.
Yes. Yes. Yeah. Let's do another column afterwards. Yeah, kind of. I think so. I don't know if we're anywhere. I'm not sure.
Okay, I'll start filling in the matrix for you. So in the second column of the first row, it is 5 times 7 plus negative 6 times 2. Now I use the second row in the first matrix. It's possible I've made a mistake with the maths, so just let me know if you think I've calculated something wrong. So, up here, I've got A times B, and down here, I've got B times A. Take a close look at the two matrices. I want you to notice that we didn't get the same answer. And this is very different from our everyday experience of numbers. Say I take the numbers 2 and 5. If I do 2 times 5, I get 10. If I do 5 times 2, I get the same number. This is a difference between matrices and regular numbers. They're not the same. So most of the time, order is going to matter when multiplying matrices. Sometimes, if you set up the matrices right, you do get the same answer, but most of the time you won't. So just want to draw that to your attention because this is a common misconception that students have. If I multiply the two matrices, I get the same answer no matter what order it's in. It's not true. Actually, we just showed that. All right, let's go back to the front page now. So now that I've shown you what it looks like to multiply two matrices, let's go here. Some remarks. So the first point should be very clear now. We are not doing the same thing as we were when adding matrices. We are not multiplying numbers in the same position. We're using rows and columns from different matrices here. Now, the second point is something that's worth saying. So, when can we multiply two matrices? I didn't make this clear enough, so please add this to your sheet. To multiply A and B to get A times B, the number of columns in A must be the same as the number of rows in B. So in a moment, we will multiply matrices with different sizes. Just now we did 2 by 2 and 2 by 2. But we can have cases where the matrices have different sizes. And what we want is the columns in the first matrix to be the same as the number of rows in the second matrix. Keep that in mind as we do a few examples. Okay, flip back now. We're going to look at example 3. Okay. This is the last layer. So the other thing I need to say is if I multiply two matrices, a question that we need to ask is how big will the final matrix be? So the size of AB is determined by the number of rows in A and the number of columns in B. That hashtag is just me being lazy. I don't want to write number of 4 times. All right. So we'll get there. Okay. Think back to the very first lesson. We described the order of a matrix using the terminology rows times columns. Yeah. So this matrix is 1 by 3. And the second matrix is 3 by 1. Now, are these two numbers the same? Yes, which means that first condition is met. How big is the matrix going to be if I multiply these two matrices together? You look at the outside. The answer is going to be a 1 by 1 matrix. Why? Because there is one row in the first matrix and one column in the second matrix. So these numbers on the outside determine the matrix. So maybe I'll write that for you when you look at this later. Inside numbers need to be the same. Outside numbers tell you the order after multiplication. Okay. A 1 by 1 matrix. This is a very unusual matrix. It's a matrix with just one number. One row, one column. So let's apply the approach. To get the number in row 1, column 1 of our answer, we will use the first row in the first matrix and the first column in the second matrix. So I'm going to have a matrix with 1 times 1 plus 4 times 4 plus 7 times 7. And I'll color code it for you. 1 times 1, 4 times 4, 7 times 7. All right, can you just give me a nod if you're following me so far? If you're not following me, don't nod, and I'll know. Okay, thanks. Okay. We swapped the order here. Based on our previous experience, we're not expecting that we'll necessarily get the same answer now. Because if I change the order of matrices, I might not get the same answer. So this time, the order of the first matrix is 3 by 1, and the order of the second matrix is 1 by 3. So let's check. Always a good idea to check before you try to do something. Can I multiply the two matrices? Yeah, you're nodding, Casey. And what's the reason? Yep. And if you look at the top of the page, so on a test, I want you to write the number of columns in the first matrix is the same as the number of rows in the second matrix. So yes, we can do this. What kind of matrix is our answer going to be? Like, what's the order going to be? Yeah. So this time, our answer is going to be a 3 by 3 matrix. Okay, so I don't run out of room. So don't write this. This is what our matrix is going to look like. 3 rows and 3 columns. Remember, to get the number in row 1, column 1 of my answer, I need to use row 1 in the first matrix and column 1 in the second matrix. So my first entry is going to be 1 times 1. Now I'll go across to the next column. 1 times 4. 1 times 7. Now I'm here. I'm in the second row. If I'm in the second row, I need to use row 2 of the first matrix. This time, it's going to be 4 times 1. 4 times 4. 4 times 7. Now I'm in row 3. If I want the third row of my answer, I need to use the third row of the first matrix. So I'll end up with 7 times 1, 7 times 4, 7 times 7. Alright, can I move to a different page? Anyone still writing? Okay, first of all, thank you for your patience. I know I've been lecturing for a very long time, so I'm going to skip the next two. Let's finish with example 4, and we'll continue with this sheets in the future. Alright. A is a 3 by 2 matrix, and B is a 2 by 4 matrix. Based on this information, what do we think the order of A times B is going to be? 3 by 4. We use the outside numbers. Alright, now, I know you're probably sick of writing all that working out, so now we can use the CAS calculator. So grab them out if you have them. I need to show you how to find the matrix entry on the CAS. So for this topic, you are at a big disadvantage if you don't bring your CAS calculator to class or to an assessment, because you don't want to be doing all of this by hand. All right, so just a new document and a new calculator. And this is the button you want to use. So it's right underneath the delete button next to the book. So click on that, and then a menu will pop up.
Where?
Yep, so the delete button, and then underneath on the left, there's a few boxes. So click on that. And when the menu comes up, there's sort of four that will be useful. The one that we want for this question is the 3x3 one. This one lets you put in a matrix that's any size. So let's start with matrix A. It has 3 rows and 2 columns. So you need to change the second box to 2. And once you've set the dimensions to what you want, press OK. Give me a nod once you have entered the matrix in. All right. So our goal is to find A times B. So we need to press the button again to enter the second matrix. Sorry? I think you deleted your document if you've done that. You might have to type it in again. Okay, look at matrix B on your sheet. This time the shape's different. Now there are 2 rows and 4 columns. All right, go ahead and type in your numbers. So before we evaluate the answer, think about this. The answer is going to be a 3x4 matrix, so there's 12 numbers. And every time I calculate a number, I need to do 2 multiplications. So if I did this by hand, there's a very high chance that I make a mistake somewhere. So in practice, most of your work will be done with the CAS. You're not going to do it all by hand, but I want you to know how to do it by hand. You gotta earn the right to use the calculator. It's the understanding first, okay? But just like that, it spits out the answer. Now, feel free to copy that into your sheets. The main point of this is that you know how to do it on the CAS. We'll revisit this again next week to give you some practice. Now, imagine I swapped the order. I claim that we can't do this. If I want to do B times A, it's not going to work. And I don't want you to just say the calculator gave me an error. I want a mathematical reason for why we can't do this. What did we need to happen if we were allowed to multiply two matrices? Inside numbers. Now, if I wrote 2, 4, and 3, 2, those numbers are not the same, but I'd like you to explain that in terms of the number of rows and columns in each matrix. So this is B. B is a 2 by 4 matrix, and A is a 3 by 2 matrix. So to be very, very specific, I need the number of columns in B to be the same as the number of rows in A. So here's what I'd like you to write on a question like this. BA is undefined because the number of columns in B is different from the number of rows in A. Don't have to write this, but definitely want you to write this. That sentence at the end. All right, you've been great. Thank you for your attention. I hope I haven't lost you, but this is the third time I've tried to teach matrix multiplication to year 11s, and I'm hoping it was the best out of the 3 attempts. So I'm happy for 4D to go over more than one lesson, so I reckon we can start it today, and we will review it next Tuesday. I think a quiz in the near future is also in order as well. So let's say today 4A to 4C must be finished, and you should start 4D over the weekend. Okay, so 4D, I'll specify which questions are homework over the weekend. Yeah, you are. Yeah, you are. Say questions 1 to 5.